Hi everyone, welcome back. Hope you are doing good. This is Mahesh. This is a continuation on array series. So in this video, we will try to understand how to search for an element in an array. So before starting with how to search, let us try to understand what we are going to solve or how we are going to solve the problem in this entire series. So basically, first we will try to understand the problem statement. So that's the main thing, because we should understand the problem properly, then only we will be able to solve it in a right way. Then we will try to understand constraints. So constraints is one of the main thing what we need to consider before proceeding with the solution. Then we will pause for a second, and you can pause the video and think for some time for the solution. And once after that, you can come back, and then we will see what is the idea or intuition behind this particular problem. Basically, I mean, whenever an interviewer asks for any problem, he will have something in his mind that he wants to evaluate you based on something. So that we will try to understand, and then we will try to come up with a brute force solution. And then we will see what is the time complexity and space complexity for the brute force solution. And then we will try to optimize the solution, and then we will try to come up with time complexity and space complexity for the improvised version. Then we will move on to the implementation. So this is the standard way which we are going to follow in the entire series. So with that, let's move this aside and let's get started. So as per our pointers here, first let us try to understand what we are trying to do here. So basically, there is a given array, and in that, I mean, we are trying to search for some element. Okay, so here this is the array given where it contains certain elements, and there is a search key, and we will have to search in this particular array, and we will have to come up with whether that number exists or no. It can be asked in different varieties. Some questions they only ask whether if the number exists in the array, then we might need to return either true or false based on that, or sometimes they might ask the index of the number. So here basically we will try to return the index. So if we know the index, then we can also easily return true or false, right? I mean, if the number is available in the array. So that is the first thing. I mean, we understood the problem statement. Then we will try to understand the constraints. So here numbers can be in any order, okay, and numbers can be either positive or negative, so whatever it might be. So that is what is the constraint. Now you can pause for a second and you can think for its solution, then you can come back. Okay, now let us try to understand why this question will be asked. So normally in a real-time scenario, assume that there is some results that are announced, and the result contains only the qualified student names. So in the qualified student names, what you want to search? You want to search for your name, right? So in that case, so how do you search? So you basically scan through the list, and if the name exists, then you say that you are qualified, otherwise you are not qualified. So that's how the practical example comes up for this searching algorithm. So now, as I said, what we do normally, we will scan through the elements. So in this case, what we will do, we will try to scan. So we know our search key is 8, right? Now what we will do, we will start with the first element. Is it 8? No, it is not 8. Then we will move to next element. Is it 8? No, it is not. Then we will move to next element. Is it 8? No, it is not the case. Next we will move to next element. Now we got 8, right? So once we get 8, either we will return true or we will return its index basically. So the indexes are something like this. So once we find the number, we can return its index 3. So for that, what we need to do, we need to iterate over the array, we need to iterate through the array, then we need to compare each element with our search key. Okay, so if we want to do that, let us try to look into the pseudo code for this one. So what I will do, let's say I have a method called search and it contains array, okay, and then it contains search key. Okay, so if that is the case, now first what I will do, I will check whether there are any elements in the array or no. So if there are no elements, then there is no need to search, right? So that is our one of the constraints maybe. So how to search or how to check whether the array contains elements or no. So for that we need to check the length. So maybe its length maybe is n. So what I will do, I will take a variable, maybe it's a integer or whatever type. So since it is a pseudocode, I don't mention any type here. So n will be, so a dot length or a dot size, something like this. With this, what we will get to know, we will get to know the size. Then if n is equal to 0, so if there are no elements, then what we will do, we will simply return. So if they ask index, maybe we will return -1, or if they ask either true or false, maybe, I mean, there is nothing to say something is found, so maybe we can return false. If that is not the case, then what we can do, we can iterate over the array. The iteration, how we can do, we can use a for loop. Since it is a 0 based indexing, so what I will do, I will start from I equal to 0, then I less than n. Since it is a 0 based indexing, so there will be n 0 to n minus 1 elements, or 0 to n minus 1 index. So I less than n, I plus plus. Then what I will do, I will use a if statement. If a of I, which will give me access to the element at ith index, is equivalent to my search key. So if I get something which is my search key, then what I will do, I will return my index. Okay, so this will do until the array gets exhausted, and in between, if at all at any moment, if it finds the element, then it will simply return from there. It won't continue further, it will return from there. So it will return the index, or you can also return true from here. Okay, if we are only expecting either true or false. Then after that, I will close this for loop, and at the end, so if at all we don't find any element in this entire array, then what we will do, we will simply return -1 or false. Okay, so this is how the pseudocode looks like. Now let us try to do a quick dry run. So now let us consider this example only. 21, 15, 7, 8, 3 and 5. Search key is 8. So it starts first, n value will be the length of this particular array, which is 6. So n will be 6. N will be 6. So 6 is not equal to 0. So it won't execute return -1 statement. So it will come to the next statement, which is for. So now it will start from I equal to 0, which means this particular index. Now it will check whether this 21 is equivalent to our search key. So that is not the case, right? So what it will do, it won't go inside. So it will continue for the next index. So now it will go with index 1. Then it will check 15. 15 is not equal to 8. So it will skip the internal statement. Then it will move to next index. Okay. Now it will check 7. 7 is not equal to our search key. So it will continue again. Now it comes to 8. Now we found the element. So we found the element. Then what I do, we will simply return that particular index. So index is 3, index is 3 in this case. So the loop won't continue after this, it will simply return us the index. Let's look into a negative scenario where a number does not exist in the array. So let's assume our search key is somewhere 20, so which is not there in the array. So in that case, how our code executes? So let us take I, and this will be a of I. Okay. So let our array starts from 0, or our for loop starts from 0. So a of I is 21. It is not equal to 20. So next it will increment I. So I will be 1 now. My a of I will be 15. It is not again equal to 20. So again I will be incremented. It will be 2, and a of I will be 7. Again it is not equal to 20. Now I gets incremented. It is 3. Now element a of I is 8. It is again not equal to 20. So it will move forward. So I will be 4. Element is 3. Again not equal to 20. I will be 5. Element is 5. Again it is not equal to 20. Now it exhausted the array. Now if you see the code, if it finds anywhere the element, then only it will return that index. Otherwise it will simply complete this for loop, and finally it will return us -1. So what it returns? It returns us -1 as the result. What does this mean? The element is not found in the array. Next step, we want to check the time and space complexity. So what is the time complexity for this particular code? So it is of order n. It is of order n. Why? Because we don't know whether our element is at the beginning or is at the end or is at the middle. So we don't know. In worst case, we will have to iterate through the entire array and we will have to find the element. So that's why the worst case time complexity is of order n. What about the space complexity? So we are not using anything extra other than few variables, which is n and some variables inside this for loop. So we are not using anything extra. That's why the space complexity is of order 1 for this particular code. Okay. So this is the time and space complexity. Now we will see, is there any optimization possible? So here for this problem, it is already in the optimal state because we don't know whether the given numbers are in their sorted order or something like that. So if in this case, so the worst possibility would be we will have to check for each and every element. That's why it is already in its optimal state. So for optimal code only, we have got the time and space complexity as order of n and order of 1. So with that, so one more thing what we can understand, there would have been optimization possible if the elements were in their sorted order, but it is not the case here, right? I mean, they are not really in their sorted order. So if the elements were there in sorted order, then we would have used binary search, which we will discuss in the later videos. But for this video, it is already in its optimal state. So let us now look this code in action. So I have created a linearsearch.java file here, and in that I have a public class linearsearch. Let me create a public static void main method, and before continuing in the main method, let's implement the search method. So public static return type is int, which returns as index. So search it accepts integer array A and then int value, which is a search key. Okay. Now inside this, now first let us create a variable int n which will hold array length. Then after that, check if A is equal to 0. If it is 0, then simply return -1. Sorry, we need to check not A, we need to check n because we want to check the length. Then after that, let's use a for loop int I equal to 0, I less than n, I plus plus. Okay. Now let's check if A of I is equivalent to our search key. If this is the case, then what we will do, we will return the index. If that is not the case, at the end of the for loop, we will simply return -1, indicating we did not find the search key. Okay. Now this is our search method. Now let us try to call this search method and validate it. I will first create integer array A equal to, again, some elements 21, 15, 7, 8 and 3 and 5. So this is my input array. Now what I will do, I will declare a variable int answer and I will call my search method with search key initially 8. Now what I will do, I will print system, this is error, system dot out dot println, then I will print my answer here. Okay. So with this, let us execute and see what it gives us the output. If you see, we get output 3 because that's the index of our value 8. Now let us try to give some number which is not there in the array, which is 20. Then if you execute this code, if you see, we will get -1 as the output. That is how the linear search works. That's it in this video. Hope you like the content. If that is the case, please consider subscribing to my channel and also like the video and share it with your friends. Thanks for watching the video.